Is that okay? Fine now?
Yeah, sir.
Okay, good. Okay, so this Catia V5 is really high-end software, we can say. So this software is used in aerospace industry and automotive industry, and this is even the license is very expensive. The small companies cannot afford it. You know, small companies, small companies, they can't afford. That's the reason they are migrating to some other softwares which are cheaper. Okay, this is high-end software, we can say. uh, the even flights and aeroplanes are designed using this software, and so all high-end cars and big players in this industry, automotive giants, we can say, those giants are using this software. Okay, and if you're expert in this, you have really a lot of opportunities in this. Okay. So what is why it is known as interactive? Interactive, you know, CATIA stands for computer-aided three-dimensional. Three-dimensional because we are going to create 3D. 3D we are going to create. Okay, 3D models. That's why it's three-dimensional and interactive application. So in old softwares, if you observe, you cannot modify the drawing, or you cannot modify the 3D model. It was very difficult. It was very difficult to modify. But in Catia V5, you can modify everything very easily. So we can say it is user friendly. Okay, and that's the reason I'll show you how we can modify it, and how even drawings, once you're after creating the drawings, so individually drawing can be modified. Okay, without, you can break the link with the 3D, and you can modify the drawing, because finally drawing is to save your time. So that's not correct method, but to save your time, so to update the drawing, you need to update first 3D, and then you have to update the 2D. So first we are going to create a 3D model, then only we are going to create a 2D model, and that's the process actually. In case if you have very urgent, then you can also modify the 2D. So how that can be done, I'll show you. Okay, so that's why it is interactive application. Okay, developed by Dassault System, and it's full of software, so which incorporates CAD, CAE, but we are more concerned about uh, this only, CAD only. Okay, computer aided designing only. CAE, this portion, again, this is different department, and the CAM, computer aided manufacturer, that is also a different department. Okay, as of now we are concentrating on CAD. Okay. Okay, so SIGMA system requirements, I have just mentioned it here. If you already uh, installed it, then your system is already supporting it. Okay, so nothing to worry about the system requirements. I just mentioned it. Okay, okay. Coming to the Catia software, it looks like this. Okay, so you have many things in Catia V5. Okay, when you open it, you have many things, but you need to learn those things which are important for you, or else it's a waste of time. You're not going to use it anywhere. Okay, for a particular project, what all things are required, those things you need to learn. Okay, if you enter these workbenches, you know, each workbench will have lot of things in that. So we are going to use part design, okay, assembly design, sketcher, and then sometimes well design. Okay, um, more if you are working on tool designs, then you're going to work on tool designs. Okay, then drafting, 2D layout. Okay, so all these, they have many things in that. So uh, you can do a research, lot of research, and you can learn lot of things here, but make sure that they are useful for you. Okay, or else only learning tool is not going to help you. Along with that, you have to have a domain knowledge, as we are discussing about design and the part, how to um, design a part and what all things we need to consider. So this is the basic idea, and this is a tool which you are going to use it. Okay, so if you have this knowledge, okay, domain knowledge and design knowledge, your value will increase, okay, in the market. And then tools, if you add tools, this is one tool, and we have other tools also. If you learn those tools also, then it is going to help you to get into the market with a very good package. Okay. Okay. So right now, let's see mechanical design. Okay, so first you need to click on the start, mechanical design, go to part design. So initially we are going to design part. Okay, so if you open, you cannot see this. Okay, this access system. So how to get this access system? Okay, to get this access system, go to tools. Okay, and then properties. Now, before this only you can go. Okay, here tools, options, and see here infrastructure. Okay, and part infrastructure. Okay, don't worry, these things we'll be using on daily basis, so you'll come to know very easily. Okay, you can remember that the first time, don't worry. And looking at all these things, there are so many things how to remember. Okay, don't worry, if you start practicing it, it's going to be very easy for you. You can remember it. Okay, part infrastructure. Okay, display in part document, create an access system. Okay, create an access system, click on this. Okay, in display you can see the access display size. Okay, you can decrease or increase, you can decrease or increase. Okay, and then say okay. You want to do any other changes, you can see here. Okay, say okay. Now go here, mechanical engineering, part design. Okay, you can see this is the access system. Okay, so after getting this access system, click here. It will show you all these details. Okay, origin is coordinates. Okay, xy plane. If you want to reverse it, you can reverse it. Okay, how you want. So how to use this again, it depends on the orientation of the part. Okay, so when you are working designing a part, okay, so orientation is very important. So in which direction the vehicle coordinates, how the vehicle facing, in which direction the vehicle is facing, and the part will be assembled in which direction, the orientation of the part as well as the coordinates of the part. Okay, to see the coordinates of the part, say more, and you can see now it is all 0 0 0. Okay, so they will provide you, the OEM will provide you the coordinates of the part, or else if you are designing on your own, then you are going to define the coordinates of the part, so that you can design it in that particular orientation and the coordinates in that particular coordinates, so that when you call it in assembly, I'll show you how to call it into assembly. Once the part is designed, then you are going to call it into the assembly. Then if you maintain this orientation and the coordinates exactly, then it's going to sit come and sit in exact position. Okay. Okay, that we'll see later. Okay. Okay. So this to design a part, or to, let's see how we just create a 3D model. Okay. Let's not concentrate on designing or part something. So let's get into this. Okay. Say part. For children. Okay. Properties. Okay. Graphics. Product. Okay. So what is the part number? Okay, when you provide a part number, say this is 001. Okay, underscore, and then say some bracket. Okay, say bracket. Okay, and revision. What is the revision? Zero revision. 00, we can say 00. Definition. Same thing you can copy here. Definition. Okay, nomenclature. So whatever the nomenclature at that time you see. Okay, so mostly front bracket, you can say front bracket. Okay, description. If you have any description like the history of the part, or the part is already existing or modified, or what was the thickness, say thickness. Okay, thickness was 0.5. Okay, some description, what you want to remember, or you want to refer once it is completed. And then history you want to see, you can make something here, mention something here, so that you can remember that. Okay, once you apply, it will appear here. Okay, you can see 001 part. Okay, so these are the best practices you need to remember. Okay, so first, remember this. Okay, the product, you can do all these things. Okay, all this information is very important. Okay. Okay, after that, you can see you have planes here. Okay, these are the planes, default planes. Okay, xy plane, yz plane, zx plane, and we have axis here. Okay, because we inserted this axis. Okay, we created this axis, and then we have a geometrical set here. Okay, this is the geometrical set. What is the use of geometrical set? I'll tell you. Okay, so as of now, let's close this, hide this. Okay, and now, so for example, we are going to create one part, simple part. Okay, let's consider this. And what is this? This is the sketcher. Okay. So always, I'm teaching you what is required for our project. Okay, first let us learn those things, and you can do R&D, research and development, and then you can find out what is the other things. Okay, other options. There are so many options. For example, see, we have a position sketch, we have a sketch, normal sketch. What is the use of position sketch and normal sketch? Normal sketch, in normal sketch you will not have control on the origin and the orientation. Okay, you cannot control the parts or orientation as well as the origin. The coordinates you cannot have. That's the reason never use. Okay, always go for this position sketch. Okay, once you click on the position sketch. Okay, it is position. Okay, and again, it depends on the part which you are designing. Okay, so based on that, you want to keep this origin point as part origin. Okay, that it depends on the project requirements. Okay, if OEM says, or Tata Motors says, that for every point the axis should be at the origin, then you have to see again what is the definition of origin, what is the parts origin, that will be defined by the assembly. When you see the part in
Yeah.
assembly, so you have to define which is the origin. Okay, so for everything, projection point, okay, for everything there will be reasons. Okay, we need to justify the reasons, and then we have to go on. Okay, that by practice you'll learn it. Okay, as of now, let's see, let's consider as part origin. Okay, okay, so uh, now this is the vertical position, this is the horizontal position. Okay, so is that okay, or you want to change the orientation of the part? Okay, so if you want to change the orientation of part, then click on this reverse H. Now the H is reversed. Okay, you can see it here. And you want to reverse the V, okay, reverse it. Or you want to swap it, you can swap it. Okay. Okay, I consider the default one. Okay, default orientation. Okay, let's consider the default orientation. Okay, and now this is the sketcher. Okay, so you can see what all options are available here. So first thing what you have to do is just right click, okay, and say customize, and then toolbars, and then say restore all content, say yes, restore position, say okay, okay, then close it. Now all the tools available here will be in proper location, proper position, okay, or else they will be in the air randomly, they will be in the air here and there, so you have to search it. Now if you do that, all the tools will be in position, in their original position, default position, whenever you open it. So again I'll show you how to do that. Okay, right click, okay, where to right click? On this bar. Okay, you have to right click, say customize. We'll do it daily so that you can remember. Okay, go to toolbars, restore all content, say yes, restore position, done. Okay, and please, if a few tools are not in position, please place them. Okay, okay, now what you can see here, you can see a toolbar. Okay, so I'm going to take this, some part I'm going to create. Okay, so it looks white now, white in color. That means this is not constrained. Okay, this is free, this is in the air, you can move it anywhere, you can just compress it or you can do anything. So any part, if it is in the air, you have no control over that, so it should be controlled. So how you are going to control? You need to constrain it. Okay, so that's the purpose of this axis system. Okay, so this axis, so the best practice is always create one line here. Okay, instead of giving directly to axis, axis to axis also you can give. For example, I'll show you how axis to axis. So for example, this is the tool which will help you to dimension it. Okay, so now this dimension I have taken. Okay, consider this dimension also too, must be given from the okay, this is one dimension with the horizontal and another dimension with vertical. Okay, from here to here. Okay, so always follow this practice. Okay, two dimensions must be given from the one from the horizontal, one from the vertical, and then the other dimensions using the lines, the other lines of the part. Okay, other face of the part. Now this is green. Okay, once you start constructing is constraining it, the whole thing will become green. Now this is completely fixed. Okay, this your design is not going to move, your sketch is not going to move in any way. For example, you can just move and see. Okay, you cannot move it, you cannot move it. Okay, in case if I delete this, then try. If this is white, then move it, it will move. Okay, so first thing is, first and foremost thing, we always need to constrain it. Okay, that means the freedom should be arrested. Now they are not free. Okay, so your sketch is done. Okay, now everything is green, so your sketch is done and it is good. Now let's come out of this. Okay, again I'll go back and show you how to come out. You can see here exit. Okay, exit workbench. This is a sketcher workbench, this is known as sketcher workbench. And now you're coming out of this, and now you can see the geometrical set. Okay, now the sketcher a sketch is inside the geometrical set. That is the purpose of this geometrical set. Okay, that is the purpose of this geometrical set. Okay, and now let's try to, it is saying the current in work object isn't in a body. Okay, if you are using 3D, if you are converting it into 3D model, then it should be in a body. So it automatically takes this body. So part body will be utilized now. Okay, you need to say define in word, or even if you don't say, that's automatically going to take that. Okay, so now let's, have you observed one thing? Only these options can be used here. Okay, so with this sketch, only these options are highlighted, the other options are all off. You cannot use them unless you use these options. So these are the options, you have to use it first. Okay, so this one, click on this. Okay, what is this? Pad definition. You are going to create a pad here. Okay, so we have created a pad. So how much distance that I didn't show you. Okay, this is the length of the pad. Okay, 20 mm. Okay, so here so many options are there. I will show you how to use all these options. Okay, but today let's have a look at this basic step, how to create a pad like this. Okay, and then what other information is available here. So length is 20 mm, so 20 mm of distance it has taken. Okay, the thickness of this pad is 20 mm. And then selection, which what you selected, you have selected this sketch, so that's the reason it is going to show the sketch one here. And then you can see thick here. Okay, if your pad is uh, may if it is a part which contains thickness, then you have to use this thickness. Okay, then again you can see a lot of information here. So 1 mm thickness, if you say, let's first see the pad. Okay, this is the pad. Okay, this is the pad, and how to measure it, how to see how much is the thickness, you can use this tool. Okay, this, you can see this tool, click on this and just click here. Okay, see this face and this face, here it is 20 mm. Okay, it will show you how much is that. This face and this face is 20 mm apart, and angle is 0. They are parallel faces. Okay, they are parallel faces, that's why there is no angle between these two faces, but the distance is 20 mm. Okay, okay, now once your pad is done, okay, once this part is created, then you can see all other options are highlighted. Okay, now you can use all these options, all these options you can use. Okay, for example, I want to make a hole here, a pocket. A pocket is nothing but, if you want to make a hole here, you can use this. Okay, Now how I'm going to do that? Just click on this. Okay, click on one of the faces, or directly you just create one sketch. Again, go here. Okay, say default and take a circle. Okay, I'm not constraining it. Okay, it should be constrained. Okay, and now I've selected this face. Now I want to have a whole of this much. Okay, so pocket. Okay, let's say this is reverse side it is going. Okay, so say reverse direction. Okay, 20 mm. You can have a hole here. Okay, and how it is shown here? See the tree. This is the history. Okay, you need to rename everything. Again, this part body should be renamed properly. Okay, go here, and then it should be renamed like what you renamed it here. Okay, and if you want to increase the graphical properties, you can do that. You want to change a uh, part, see part color, you can see the part, change the part color. Okay, how? Say apply. Okay, part color is changed. And transparency, if you want to increase the transparency, say apply. See now the whole part is transparent. Okay, so I have a lot of features, you need to study this. Okay, one by one, go one by one and see what all things are available in this. Now see the part itself is transparent. Okay, now again go back. You don't need transparency in this. Again go back, then remove this. You want to change the color, change the color, say apply. Okay, I change the color. Okay, so here you can see you also can rename it. Okay, what exactly is this? What you want to say? Base. This is the base. Okay, and what is this? Pocket one. Okay, if you want, you can keep it like this. Okay, or else you can. So and after finishing this, what is the next step? So for example, this is done. If you say this is done, I'm done with this, my model is completed, then what is the next step? Next step is creating a drawing. How to create a drawing? Okay, go to Windows, or you can directly go here, start mechanical design, and go here and say drafting. Okay, if you enter into drafting, it will ask you all the details. Okay, you want to have these details or you want to change it. If you want to change it, then you have to modify. Okay, modify it. So based on your requirements, the OEM will say which standard you need to use. As of now, we are using ISO here. Okay, if you're working on Japanese projects, then you need to use the JIS. Okay, ISO for India. Okay, ASME for America. Okay, all these things will be available. Based on your project, you need to decide and select the correct one. Okay, and this is for format A3. Okay, paper size it will show, and scale is 1:1. So whether you want 1:1 or what, you have to decide and you have to modify it. Okay, in this modification. Okay, I'm saying default I'm considering now, and I'm saying okay. Okay, now even here you have some features like ready-made drawings. It will give you, if it is if this matches your requirement, then you can select it. Okay, so for example, if you select it here, say okay first this one, and then select it here, and then say okay, it automatically creates this drawings. Okay, and this is your sheet. Okay, whatever you create, it should be inside this. So this is your front view, If you want to move the location of this, then you have to move this front view. All these side views and upper bottom view and the top view, all these views are generated from this front view. That's the reason they all are linked with this front view. If you want to move this, you have to hold this and then move. Okay, then only you can move. And this one you can move it just parallelly away from this, but up and down you cannot move. Okay, this also up and down you cannot move. And this is, as this is bottom view, up and down you can move, but left or right you cannot move. Okay, this is iso view, and again iso view can be moved in this direction. Okay, so this is your sheet, drawing sheet, and all these drawings are out of the sheet. So how to do that? How to, what is the scale required to minimize it, to make them inside the, fit them inside the sheet? So say apply, and the shape will be 1:2, and this will be communicated to you saying that if you are designing a parts and the drawing should be prepared with the scale of 1:2 or 1:1, okay, or only iso view is required in 1:1. If only iso view is required in 1:1, only go into here into this properties and say 1:1 I want to use, and this will be 1:1, and the remaining all drawings will be 1:2. Okay. Okay, so this is automatic generation of drawings. Let us see how we can manually generate it. Okay, so once you entered into this, then again you can see only front view is highlighted. All other things are not highlighted. So click on the front view, Windows, go here, and always you need to select the plane. Okay, this plane, this XY plane or YZ plane. And after coming here, you need to use this here, this provision, to see if the part is in right direction, or you want to move it up, down, okay, or sideways, or you want to rotate it. Okay, so which orientation is required, so that you can adjust here. Okay, something like this. Okay, and then you click it on this. This is generated. Okay, and now, so how to zoom in, zoom out? Okay, you need to learn that also. I'll tell you how to zoom in, zoom out, and this is very important. Initially, it will be a little bit difficult for you to do all these things. Okay. Okay. Done. And then now, again here dimensioning. So we need to give dimension here. So what is the dimension method, and what kind of, let's see, this is how we have to dimension. Okay, you can see here. Pick out this. Where is the radius? Here is the radius. Okay, so you are going to mention the radius here, and if you want diameter, then instead of radius you can give diameter. Okay, and okay, location of this hole. So how to locate that? Okay, you have to locate the hole. So what is the position of the hole in horizontal and in vertical? Vertical it is already defined. Okay, the whole part dimensions will be covered. Okay, as of now I'm just leaving it here, but this is how we have to do it. Okay. Okay, so guys, it's already 7:18 it seems. Okay, so any questions on this, guys? So there will be a lot of questions on this. Okay, So day by day, I will show you all the options available in this, and you start practicing. Okay, once your installation is done, then you can start practicing it, and then it will be easy for you. Nothing to worry. If you have any questions, then you can ask me at any time. You can send me images what you have done, or and I'll be supporting you. Okay. Okay, these options one by one we will go through. Okay, in every class, so that you can be clear on all these options, how to use this, how to uh, create drawings, and how many kinds of drawings, and how to create assemblies. Okay, everything we will do. Uh, as I mentioned, the part should be like, if you change the dimension, if you change the, so now say more, and now the coordinates are 0, 0, 0. If you want to change the coordinates, okay, 30, some 50, 70. So what happened? It moved. The coordinate system moved. Okay, I'm going to close it. Okay, close it. Say okay. Look at this. The part moved from 0, 0 to that location. Okay. Now how to check the coordinates now? Either you can get into, either you can open like this and see, or else you can use this tool. Okay. See, coordinates now, they were 0, 0. Now as the coordinates are moved, changed, now the coordinates are showing different. And then when there is a change in the 3D, definitely there will be, drawing will be asking update, so you can see the drawing is asking for update. Can you see this symbol? This is how it asks. Okay, and you just say right click and say update, and accordingly the drawing will change. See, because the part is moved, all dimensions have gone, and now you have to dimension it again. Okay, so this is how the drawing is updated. This happens many times because many changes will be there in the designing. This is a small part, that's why only small details are available. But when you design a big parts, big brackets, then many changes will be happening. Okay, sometimes you check with the FEI department, if the bracket is failing, again you are going to provide thickness, or you are going to change the coordinates. Okay, then again you are modifying it. Okay, when you modify it, again the 3D 2D will be asking update, then again you have to update the 2D as per the requirements. Okay, so that is how it goes on. Okay. Okay, guys, any questions in this? It's already 7:20, so 20 minutes extra we have taken 20 minutes extra. Okay, so let's stop it here. Okay, and please, after installation, please go through the Catia and start creating this, what I showed, simple parts. You start designing, or start, we cannot say this is a design, but this is creation of 3D model. Okay, try to create a simple parts like this. Okay, try to create, and if you are facing any difficulty, let me know. Okay, and I'll support you for in case of any trouble. Okay, guys, any questions? All good? Shall we close? right? One response, please.
Okay, sir.
Okay, thank you. Thank you all. Have a nice evening, and see you in next class.
Thank you, sir.
Thank you very much. Yeah, bye.